This podcast will teach you about orders of magnitude, a way that we count in science so we can keep numbers small and manageable. We count by powers of 10 for the most part. It's right at your fingertips. And you're already using orders of magnitude when you count. It's called money. We have a decimal system in this country. The $1 bill is the basic unit. Think of it as 10 to the 0, 1 followed by 0 zeros. A $5 bill would be 5 times 10 to the 0. A $10 bill is 1 followed by 1 0, or 10 to the 1. The $20 bill, 2 times 10 to the 1. $50 bill, 5 times 10 to the 1. Step up a little bigger, the $100 bill is 10 to the 2, or 1 followed by 2 zeros. $500 bill, 5 times 10 to the 2. $1,000, that's 10 to the 3. There are still a few $5,000 bills, 5 times 10 to the 3, and $10,000 bills, 10 to the 4, circulating. Right, $25,352, 2.5352 times 10 to the 4. Notice that in orders of magnitude, we always try to keep just one digit to the left of the 0, and then all the other digits follow to the right of the 0. And we make the number with the exponent as large as possible. This is just a standard way of doing it. Every now and then, someone tries passing a 10 to the $6 bill. They're not real. They're bogus. A neat thing about orders of magnitude is that you can go in the opposite direction just as easily. A penny is 100th of a dollar. So we could express a penny as 10 to the minus 2. Now notice here that it's not the number of zeros after the decimal, but the number of places after the decimal. A nickel is 5 times 10 to the minus 2. A quarter, 2.5 times 10 to the minus 1. Could also write it as 25 times 10 to the minus 2. But again, the standard is just to have one digit to the left of the decimal place. You can multiply and divide with orders of magnitude, but there's a little bit of addition involved. So 3 times 10 to the 8 times 2 times 10 to the 4 becomes 3 times 2 multiplied by 10 to the 8 plus 4, or 6 times 10 to the 12. That is, you have multiplied 300 million times 20,000 and gotten 6 trillion. To divide, 3 times 10 to the 8 divided by 2 times 10 to the 4, that becomes 3 over 2 multiplied by 10 to the 8 minus 4, or 1.5 times 10 to the 4. 300 million divided by 20,000 equal 15,000. You cannot subtract or add orders of magnitude directly. The exponents all have to be the same. 10 to the 6 minus 10 to the 5 is not 10 to the 4. You have to change it so it's 10 times 10 to the 5 minus 1 times 10 to the 5. That gives you 9 times 10 to the 5. In other words, 1 million minus 100,000 equal 900,000. In your homework assignments, if you don't want to do superscripts, feel free to write it as 10 with a caret sign 2, or 10e2 for 10 squared, or the same with negative numbers. 10 with a caret sign minus 7, or 10e minus 7. Just use it consistently so I can understand what your answer is supposed to be. Another unit of measure that we use is the mass or the size or the distance of different astronomical bodies. A discussion of extrasolar planets, large planets in other solar systems, might use the mass of Jupiter as a reference point rather than the billions of kilograms that Jupiter actually weighs. We would also express the mass of Jupiter as 317.8 times the mass of Earth. or the radius of the Sun is 109.2 times the radius of Earth. We express the distance from Sun to Earth as 1 astronomical unit and use that as the yardstick in talking about other solar systems. Subsets or variations on these numbers can be expressed graphically as a logarithmic scale. And in this, which we use in the map of the universe, you will see the spacing between the numbers on a number line getting tighter and tighter as you move from 1 to 10. And then that 10 becomes the 1 for the next sequence, and so on. It's a little bit different from a linear scale, and you have to pay attention when you're measuring points in between the numbers. We use this 1 Earth radii in this logarithmic scale in the map of the universe as the yardstick for measuring the universe itself. So we are at 10 to the 0 Earth radii from the center of Earth. The Big Bang is at 10 to the 20 Earth radii distant. You can see how much easier it is to write that as 10 to the 20 than trying to write down all those zeros and, of course, losing track of them. So start counting your change, your money, in orders of magnitude. If anybody looks at you funny, just tell them that your astronomy teacher told you to do it. And if you get arrested for asking to play with the $1 million bill at the bank, don't call me for bail.